Imagine a giant rock, bigger than a sports stadium, hurtling through space, dark, cold, and moving faster than any bullet. Now picture that rock on a collision course with Earth. This isn't science fiction, it's a rare but real threat. An impact would unleash energy equal to thousands of nuclear bombs, creating a fireball brighter than the sun and flattening cities for miles. The devastation wouldn't stop there. Dust and debris would fill the atmosphere, blocking sunlight for months or years. Without sunlight, plants die, animals starve, and the climate plunges into a long, dark winter, just like what wiped out the dinosaurs. Our solar system is a cosmic shooting gallery, filled with millions of asteroids and comets. Most stay in the asteroid belt, but sometimes, a gravitational nudge sends one toward Earth. Scientists call these near-Earth objects, or NEOs, and they're constantly scanning the skies for them. Finding these threats is the first step in protecting our planet. The challenge is enormous. How do you stop something so big and fast? Engineers and astronomers are racing to answer that question. Understanding the enemy, its size, speed, and composition is crucial. The future of our planet could depend on the solutions we develop. It's a massive responsibility, but it all starts with looking up. The threat is real, but so is our ability to fight back with science and technology. Our survival may one day depend on what we do today. Asteroid impacts aren't just movie plots, we've had real close calls. In 2019, Asteroid 2019 OK, the size of a 30-story building, zipped past Earth closer than some satellites. We spotted it only a day in advance. If it had hit, it could have destroyed a city with the force of thousands of Hiroshima bombs. In 2023, another giant, 2023 MK, came even closer than the moon. We had just 13 days warning. These near misses prove our detection is improving, but it's far from perfect. Many big asteroids remain hidden, dark, fast, and hard to spot. Comets are even trickier. They come from the solar system's edge, are harder to track, and move faster. In 2020, Comet Neowise was discovered only 4 months before its closest approach. If it had been aimed at us, we'd have had no time to react. Each close call is a wake-up call for scientists and the public. We need better telescopes, more sky watchers, and a real plan. What if we found a true impactor with little warning? The universe is busy, and it's only a matter of time before another big space rock heads our way. These events aren't meant to scare, they're reminders to take the threat seriously. Every near miss teaches us about detection, response, and the need for preparation. The next warning might be our last chance to act. Are we ready? To stop an asteroid, you need to know what you're dealing with. Some asteroids are solid rock, but many are rubble piles, loose collections of gravel and dust held together by weak gravity. Imagine trying to punch a cloud of gravel. That's what makes stopping them so tricky. These objects travel at up to 70,000 kilometers per hour, about 60 times the speed of sound. Even a small asteroid at that speed packs devastating kinetic energy. Comets are different, icy, fragile, but even faster, up to 140,000 kilometers per hour. Their speed makes them even more destructive than asteroids of the same size. So, we face two main threats, solid or rubble pile asteroids, and super-fast, fragile comets. Each requires a different approach. A method that works on a solid rock might fail on a rubble pile. A plan for a slow asteroid won't work on a comet. Understanding these differences is key to any defense. The wrong move could make things worse. Scientists study asteroid and comet composition to design the right solutions. Knowing what's coming is half the battle. The other half is acting fast and smart. Every space rock is unique, and so is the way we must stop it. The clock starts ticking the moment we spot one. Preparation is everything. The best defense is an early nudge. If we spot a threat years in advance, we don't need to blow it up. Just change its speed by a tiny amount. Even a millimeter-per-second shift can make an asteroid miss Earth by thousands of miles. NASA's DART mission proved we can crash a spacecraft into an asteroid and alter its path. Other ideas include painting one side to reflect sunlight, or using lasers to heat the surface and create a gentle push. These methods work, but only if we have years of warning. If we discover a threat just months or weeks before impact, gentle nudges won't cut it. We'd need a much more powerful solution. The key is time. The more we have, the more options we get. Early detection gives us choices. Late detection means we need force. The clock is always ticking. Sometimes we have to act fast, or not at all. Hollywood loves the idea of nuking asteroids, but reality is far more complicated. Landing on a tumbling asteroid to plant a bomb is nearly impossible. Microgravity makes drilling and anchoring unworkable. Detonating a nuke nearby doesn't work well either. In space, there's no air to carry a shockwave, so most of the energy just radiates away. A standoff blast might only create a small crater, barely changing the asteroid's path, slamming a nuclear warhead directly into a fast-moving rock. The bomb would likely be destroyed before it could detonate. Nukes are powerful, but space is unforgiving. The most obvious solutions have serious flaws. We need smarter, more reliable methods. The right tool for the job isn't always the biggest explosion. Science fiction makes it look easy, but planetary defense is anything but. Real solutions require precision, not just power. The wrong move could make things worse. We need to think beyond the movies. The stakes are too high for guesswork. The next impact could be our last. Enter the cosmic bullet, a dense metal rod like tungsten, placed directly in the asteroid's path. Instead of firing at the asteroid, we let it crash into the stationary penetrator at its own incredible speed. The impact releases the asteroid's own kinetic energy, vaporizing rock and drilling deep inside. This isn't a gentle nudge, it's a shattering blow. The pressure from the impact can break a rubble-pile asteroid apart, turning one big threat into thousands of harmless fragments. The debris cloud would burn up in Earth's atmosphere, creating a meteor shower instead of a disaster. This method works even with just weeks of warning. We already have the technology, rockets, navigation, and heavy metal rods. The cosmic bullet is practical, powerful, and fast to deploy. It uses the asteroid's speed against itself. No need for complex bombs or risky landings, just precision, timing, and physics. For short-notice threats, it's our best shot. Sometimes, the simplest ideas are the most effective. The cosmic bullet could be our planetary shield. Imagine a 100-meter asteroid, big enough to destroy a city, heading for Earth in 2 weeks. Panic spreads, but with the cosmic bullet plan, we have a solution. Launch a rocket carrying a 2.5-ton tungsten penetrator. The rocket races to a point millions of kilometers from Earth, intercepting the asteroid's path. The penetrator is released, waiting for the asteroid to arrive. When the asteroid slams into it at 70,000 kilometers per hour, the impact shatters the rock from within. The city killer becomes a cloud of small fragments. As the debris enters Earth's atmosphere, it burns up harmlessly. A spectacular meteor shower instead of a catastrophe. The threat is neutralized and the city is saved. This plan works with just weeks of warning. No bombs, no risky landings, just smart engineering and fast action. The right preparation turns disaster into a light show. The cosmic bullet could be the difference between survival and destruction. With the right tools, we can protect our cities. The future depends on how quickly we act. A planet-killer comet is a different beast, too massive for a single penetrator. Breaking it up isn't enough. The fragments would still hit Earth. We need to shatter it and push the pieces off course, far from our planet. The solution: a hybrid approach, multiple penetrators and a nuclear device, used smartly. With 6 months warning, we launch a powerful rocket carrying 5 tungsten rods and a nuke. The rods strike the comet in sequence, drilling a deep tunnel. The final rod carries the nuclear payload, detonating deep inside. The explosion is trapped, shattering the comet and pushing the fragments away from Earth's path. This focused, inside-out blast is our best shot at stopping a true doomsday object. It's a high-stakes mission, but the technology is within reach. Preparation and precision are everything. For the biggest threats, we need the smartest solutions. The hybrid method could save the world. Can we stop a planet killer? The answer, yes, if we're prepared. The technology exists or is within reach. Cosmic bullets, hybrid penetrators, heavy-lift rockets. We know how to track threats and design missions to intercept them. But right now, we're not ready. No rockets or penetrators are waiting on launch pads. Building and launching a mission takes time we might not have. For the biggest threats, we need to be ready before danger appears. That means building, testing, and having rockets and payloads on standby. International cooperation is essential, especially if nuclear devices are involved. Planetary defense must be a global priority. like a fire department for Earth. The universe isn't out to get us, but it doesn't care if we're ready. Asteroids and comets have hit before, they'll hit again. Unlike the dinosaurs, we can see the threat and act. Investing in planetary defense is insurance for humanity's future. Our responsibility is clear: be ready and protect our world.